Hello, in this video I'm going to give you the crash course on how to define your own objects in C#. And that is by using a class file. What we're doing here is exactly what we did in GameMaker when we made our own objects and then we created instances of them, or in Pico 8 using Lua where we would make an object and then add properties to it. That is exactly what we're doing here. We're making we're defining objects, and then we may make one or many copies of that object. In C#, that's called a class file, or a class. So what we're going to do is write a class, and the class is going to be the template or the blueprint or the cookie cutter for stamping out clones of that object. So let's look at what it takes to define an object or write a class file. Or I keep saying class file because usually you put a class in its own file, but you don't have to. You could have multiple classes in one file. So notice here we've already got our program class. What I'm going to do is make a new class down here, and I'm just going to make a class called enemy, or just assuming like we had an enemy in a game or something. So how do I define an enemy? Well, I type the word class and I hit tab twice, and Visual Studio will stub out for me a class. So this says I am defining an object, and the name of this object type is my class. Well, what if I don't want my type to be my class? What if I want it to be enemy, zombie, shot, explosion, something like that? Let's rename it here. Let me call this thing enemy. So I am defining an enemy. Well, what does an enemy have? Maybe an enemy has an X coordinate and a Y coordinate and a health, something like that. So let's add those variables to the class. So every copy of this object will have its own set of, or its own copy of these variables. So let's make a variable called X, and that's its X location in the world. Maybe let's have a Y coordinate, and let's make a variable called health, and we'll set it to 100. So what do X and Y start out as if I don't give them values? They're going to default to 0, so maybe I'll just like explicitly set them to 0. So what I've done here is I've made an object called enemy, and every enemy, and I could have 1,000 of them, has an X, a Y, and a health. Notice they're in the class. There are no functions that we've added here. Now, this gets interesting. When you make a class and you add variables to it, these variables are not visible from outside of the class. No one else can go into the enemy and use X and Y and health. They're walled off from the outside world. They're private. They're called private variables. And if I want the outside world to be able to change the X, the Y, or health, which means like maybe up here in the run function I make a new enemy and I want to change its X or its Y, I can't do that. So watch what happens here. Now that I've defined a class called enemy, I can make enemies the same way I made ints and floats and characters and other stuff. So in the run function, watch this, enemy e equals new enemy. So what I've done now is I've made an enemy. Just like I can make other things. I've created a cookie cutter for an object, and now I can make as many as I want. Now what if I wanted to change the X or Y of that enemy? What if I want to set the X coordinate of that enemy to 100 or something? Well, look what the error says. It says enemy.x is inaccessible due to its protection level. So what the heck does that mean? Well, when you add variables to an object, by default they are private variables, which means you can't access them from outside of the object. They're kind of like they're private. They're there for just internal state keeping only. So if you want the outside world to be able to access this, you have to put a magic word in front of them, and that magic word is public. If you don't put the word public in front of them, by default they are private. And notice up here that error went away. Now I can go in and I can change that enemy's X coordinate, or I could change that enemy's health coordinate. Now let's say I wanted to add some functions to an enemy. So an enemy maybe I can move an enemy left, or I can move an enemy right or something. Let's make a function called move right. So and then maybe in here I add 1 to X, X++ or something like that. Now up here in my run function, could I tell this enemy to move right? And the answer is no. Look at the error message. Move right is inaccessible due to its protection level. So what you want to do is come down here and make it public. It says this is available. The outside world can use this function. There are times when you just want to have data that's private because it's kind of used for internal state keeping. But if you want your program to be able to modify any of these variables, you generally want to make them public. So what I'm going to tell you here, just to keep this real easy, is just make everything public. Normally you wouldn't do that, but make your functions public, make your variables public, and then you can access them from other objects. All right, what else do we need in a class file? So far we've made a class called enemy, so now we can make an enemy and we can have 1,000,000 of them if we want. We've said that an enemy has an X variable and a Y variable. Those are both integers, and it has an integer variable called health, which is set to 100. Now, what if we wanted to make an enemy at a particular location? Well, we could do something like this, where we make an enemy and then set its X and its Y. Or what if we wanted to? Well, okay, so let's look at this two ways. So what we're getting at here is we need a function that creates an enemy for us. So remember way back in GameMaker we had like a create instance event. That's kind of what we want to make here. We want to make a function that allows us to create one of these enemies in a particular configuration. And there's a name for that type of function. It's a special function called a constructor. And what a constructor function does is it builds and configures the object. And a constructor, to make a constructor, you just type CTOR, short for constructor, and hit tab twice. And you'll get a constructor. So notice what I have here is a constructor. It's a function, but it's a little different from a regular function. Notice there's two things here that this is a tip-off. This is a constructor. There's no return type. Every other function has to return void, int, string, something. Constructors don't return anything. And then also, they have the same name as their object. So notice I have a class called enemy, and I have a constructor called enemy. So what this will do, this constructor doesn't take any parameters. So let's say if we don't put the enemy at a particular place, let's say when we make an enemy, it just ends up at some random location. So let me make in the class, I'm going to add a random number generator here. Random r equals new random, like a random number generator. Okay, so let's say when this enemy, when I make a new enemy, let's set its x coordinate equal to some random number, right? Random dot next in, I don't know what in our game. Let's just say the board's 0 to 100 or something, and let's set our y to 0 to 100. So now up here, when I make my enemy, see, look, I'm calling new enemy, and here I have a public enemy constructor. It's going to set x and y to a new random location. So that's what a constructor does. A constructor is a special function that builds your object. It sets it up. It kind of initializes the variables to their default location or their default values, and it has the same name as the object. So we're defining the blueprint for an object called enemy, and the constructor's name is also enemy. Now, what if we wanted to make an enemy at a specific location? How could we do that? Well, we can have more than one constructor. Let's make another constructor. So I typed CTOR and I hit tab twice. Let's say that this constructor is used to make an enemy at a particular location. So let's say that this constructor takes a parameter called x and a parameter called y and a parameter, yeah, that's okay. Let's just say x and y. So this constructor takes two parameters, an x and a y. And what do? We'll say make this object's x coordinate equal to whatever the parameter was, and then let's set its y coordinate equal to whatever the y coordinate was. So that's why I've got these the the class variables are uppercase and the parameters are lowercase, and that's so I don't end up with two parameters with the same name. I don't have a naming collision. So what this constructor does is it allows me to make an enemy at a particular place. So I can say make me an enemy at 20, 25, 25, and what will happen is I'll set that object's x and y variables to be 25, 25. So what I've done here is I've now made two constructors. All right, so let's make another function here, and I'll just say like print or something. I'll call it print, void print. So what it'll do is it'll print out the status of this object here. And let's just say console.writeLine, and actually I don't know if you saw the shortcut I did there, CW tab, and that'll expand to console.writeLine, and I'll say x plus I'll write enemy at plus x plus y, and then I'll print out the health too. Space plus health equals, and then the actual health variable. So when I call the print function for this enemy, it'll say enemy at, and then it'll put out this word followed by the variable, whatever x happens to be, followed by a comma, followed by whatever y happens to be, followed by the word health equals, followed by whatever the health happens to be. Now, can I call this function from outside the object? No, because it's private by default. So what I need to do is make it public. So now I've made a public void print object, and every enemy will have these variables, and it will have these two constructors, and it will have these two functions. So I've defined an object that has called enemy that's got 4 variables, 2 constructors, and 2 functions. All right. So now let me actually let me just show you how we can use this now. So let me make a function called, in the run function here, let me make a list of enemies here. So this is a list, and then of type enemy, and I'll call it enemies equals new list of enemy. So notice now that I've defined an enemy, I can make enemies the same way I can make integers. You know what? And actually, let's take this out of the run function, and let's put it up here in the class. So every program will have a list of enemies. And now in my run function here, let me make 10 enemies. And I hit tab twice, and it expands, and I'll say into a complete for loop, and I'll say for I equals 0 to 10. So it'll run 10 times. Enemy E equals new enemy. So so this is going to run 10 times, and it's going to make 10 enemies. And then maybe I'll add the enemy to the list. Enemies dot add E. So I'm making an enemy. I'm making an enemy called E, and then I'm allocating that object. I'm actually creating the enemy. When I call that constructor, I jump down here, and I build the object, and I set its coordinate to some random value. So now that I've created a list of 10 enemies, maybe I'll print them out. I could just print it out right here, but let's look at a different type of loop. There's a very cool type of loop called a for each loop. For each, and type tab twice, and then you just have to say for every. You can actually keep the word var, but let me change it. For every enemy, which we will refer to as E in the list, which is called enemies, and then let's just say E dot, and then let's look at the autocomplete here. This is everything that we've added to the enemy. We added an X and a Y and a health and a move right function and a print function. So let's call the print function for that enemy. We'll say, hey enemy, dump yourself out to the console. And then let me run this, and then let me just put in a console.read key or something just to kind of I could put in a breakpoint too. Just hit F9 to put in a breakpoint. All right, so let me run this and see what it does. Oh, for the love of God, I hate this. I always forget to I have to set that as the startup project. And then let's run this and see what it does. Okay. Oh, all right. So let's look at our console. So enemy at 0.65. So what's going on there? Okay. Why do all our enemies have the same coordinate? It's a very interesting problem. Well, it turns out that this random number generator that we have seeds itself with the clock. So remember we did the Fibonacci thing where we give it our random number generator a seed. Well, because we're creating our enemies almost instantaneously, they all have a random number generator that is starting with the same seed, and that's why they're all ending up with the same random numbers. So what we can do is actually we can kind of fix this if you put the word static in front of it. Static means there is one shared copy. So every enemy, there may be a million enemies, but they're all sharing the same random number generator, which is called random. So this is just a quirk of the way random numbers are generated in the .NET framework. It's very poor. It's clunky. It's bad. It's bad. So Unity actually went and fixed all this. But so that's just one kind of hack that we have to put in there to get our random numbers to work. And then let's take a look now. We made that stat, and now you can see that I've created 10 enemies that all have a different location. Let's run that through the debugger, and just watch it work. So I'm going to hit F9 here to put in a breakpoint. I'm going to run this again, and now inside of my for loop, look, when I make a new enemy, I'm going to hit F11 to step into the function here. You can see now I'm making a new object, and there I am in my constructor, and I'm setting x and y to a random number, and I'm returning. I've now built an object called E, or an enemy called E. It has and you can see the variables inside of that, and then I'm going to add it to my list. And I'm just going to keep repeating that over and over and over again 10 times until I've built out a list of 10 enemies. Okay, so now let's use that other constructor. What if I wanted all the enemies to start at 50-50 or something? Well, remember we have that other constructor that takes 2 parameters. So we have a constructor that takes no parameters, and we have a constructor that takes 2 parameters. So let's see what happens now when we run this function. And I'm going to put a breakpoint down here in our other constructor. So now when I create my enemy, look where we go. Now we're in the constructor that takes 2 parameters, and we're setting our x and our y to 50. And then we go around, we make an enemy, add it to our list, we go around our loop again, we make a new enemy, and we step into the constructor that makes an enemy at a particular location. So the parameters are 50-50, so we're going to say set this object x to 50 and set its y to 50. And now we've added that, and so that's why now we're using our other constructor. So this is very common that when you make an object, you provide the user of that object several ways to create that object. You can say, okay, just here's a constructor that takes no parameters. Just make me some sort of default object, whatever. Or you could say, I'm going to give the user a constructor that takes parameters and allows the user to create that object in a very specific configuration. So that's how you make your own objects. You have to define a class. Inside of that class, you have to add the variables that define that object. Its position, its sprite, its health, its speed, its direction, whatever your object happens to need. You have to add a constructor to initialize that object and set its variables to the starting values that you want. And you can have more than one constructor as long as they have different parameter lists. And then you want to add functions to that object that allow you to tell that object what to do, like chase the player, shoot at the player, die, go back to the, move toward this position. So think of these public functions as commands that you can tell this object to do. So that's what and then finally, once you have your object defined in a class file, you can create instances of that type using the new operator. So once you've defined a class, like we've made a class called enemy, now we can make enemies. Like enemy is a type now, just like int is a type, and string is a type, and char is a type, and bool is a type. We've defined our own objects, and now we can make copies of it using the new operator, the new keyword, followed by one of our constructors. So there you go. That's how you make objects. Not a whole. There's a lot more to it, but that's about the that's the crash course. That'll get you up and running. I would just say, to make a new class, all you have to do is just type class tab visual, give it a name, and then you put the variables in there, make them all public. Make some constructors, ctor tab. Right now you've got some constructors, and remember to make everything public so you can use those functions externally. All right, I know that was kind of speedy, but a class defines the type. That's how you're making the cookie cutter for stamping out the cookies. So that's how making your own objects works in C#. If you have any questions about how this works in either from this video or in the subsequent activities where you have to make your own classes, just talk to me, flag me down, email me, whatever, contact me through Google Classroom, through Schoology, whatever we're using, and I will be happy to explain it again and give you some more examples.